So, hey everybody, welcome back to today's video. Today I am doing something a little different. In fact, I'm going to be going over my last 3 months of code, specifically this month, but there has been quite a lot of changes as you can see here, and I'm just going to go over it. But now that I actually have a full game mechanic down, it's time for me to actually play the game myself and enjoy what I created. So let's go ahead and dive straight into it. Now, I already did this beforehand. This is where all these notices come from. You have stuff like adding the buffs to the players, stamina checks or entities, recursive file helpers. These are mostly like ideas I add onto the game. And then another thing too is just all that. So I'm gonna go ahead and start it since it is officially 3.0. So what we have right here is the new lighting system. And essentially I've create it because there was a lot more in depth and out of my area. But the more imperative thing is that I actually had to use it and learn it right as I was making it. Like you'll notice as soon as here, you have the object now, the artifact. This is the artifact showcase where you're going to be collecting it. It displays the artifact and it will be moving soon, but you'll see the shadows, see it going down, actual interactions. And this is definitely a whole lot better than what was here before. Now, if I come here to the editor and actually show you all the data, here we have the lighting. This is where everything goes on in the world. So the status currently just classifies how big the shader map is and what object is casting that shader. Like the moonlight is specifically for the sun. This is the directional light for the area that casts all the and creates all the shadows. Now here it says active lights. This is just the limit currently for how many shadows I can cast, how many light sources I can have inside the game. This is a limitation to my own ability, but also might be very helpful in creating a scene and actually just identifying where to keep light and stuff. It can make everything a lot more dramatic. Now you already have your atmosphere settings. This is just what everything looks like. You have the shadow settings. This is how all the shadows are baked into the, well, not really baked. It's actually real time inside the map. Doesn't apply to the player yet. And then we also have the flashlight. Now the flashlight is specifically for the player. Like, and then look around, you'll see the flashlight right here. This is a big shader that you have for objects and stuff. And of course you can't see it inside the abyss. And then here we also have another creator window to create the lights. This allows me to add a point light or directional light inside the scene, actually select the lights and what the type of light or their location, just like the placement panel that you have for objects, just like simpler right here. It's a little more, it's a lot even, it's a lot more direct, a lot more like located, but it gets the job done. The ice one is the actual interactable object where you can activate this wall we have right here. This wall is just a normal wall. It's gonna be like a little doorway later on, so you can get started, but we just gotta make sure everything works for the moment. That's where we're at the moment. You know, watch this, complete it, wall's gone, and we now have. So compared with where we started, just like we start to finish with the project, that's how I'm going to be going over. So the first thing we have right at the moment is going to be the CMake. The CMake is still the most important. This is where the whole build collects, that everything collects, and the whole function actually gets released into Windows, to get Linux and OS, Mac OS specifically, so everything works. So as you'll see with a lot of CMake projects, you have the release version, that's a normal. You have the CMake version, that's normal. And then I have the production build. Now there's an error going on with production build whenever it is turned off. I do not know what that error is specifically, but I am not also worried about it because my game is not production ready. Enable hot reload for MSL compilers is supported. Absolutely. I have, now that I finally took the time to actually play around with it, I've got it to work and it has been amazing. As subdirectories files, you'll see around here that this hasn't really had many changes, and all the changes that I did make, I've mentioned it beforehand. Like this is mostly ChatGPT off of ChatGPT from another project that I got from another course. It was a long road. I just copied it into here and it worked. And then I also added it, also made adjustments like this project name public, and then game layer and platform layer for the project to work. And now still the two biggest things I added to the project during this last month was Fmod and Steam. The biggest things right now with those two is that with here, the project name post build copies all directories from the resource directory specifically into the resource directories, copies it into the output directories, and then the actual target, once again the CMake project name, the build target, will just copy everything from the target file directory or fmod to the actual runtime DLLs. Then Steam has to do it itself. That's how we build the game, and that's how we function it. Is what you want to do, you actually want to hold your game inside of a different file so that way it is not affected by anything. Like here, the game main just runs the actual game. It sets up these settings, it sets up the audio manager, initializes the audio devices, and then it loads all settings. A big thing is that now we did load up the settings first. We can actually use the lighting system, which is new, and then load up both the lighting settings and the assets for it, which is why you see this here. That's why you see the scene manager. It gets initialized into the instance, and then we just set up the scene camera, even though it gets like erased immediately. Last thing we do, we just push it. Now, update game is still straightforward. Close game still straightforward. Make sure you put up the backup, bro. That backup is gonna be important. And then lastly, the lighting system actually gets shut down because all the materials and copies of shaders are still in the memory, which tries to dangle. And since it is the last thing for it to be called on, since it is the memory, you gotta invoke close game before the window actually closes. So the next thing we actually do is whenever we load up a scene, the next thing is going to be creating that scene manager. The scene manager is still the same as usual, and actually what we do, we still have the cast player to entity. We cast the editor and the player straight to the scene camera, and we're also going to be doing the same thing to the camera 2D, but it's not. That's why we have this set camera function that has yet to actually be implemented, or actually used, not implemented. So you'll see here, you can create it, allocate the memory size for the pointer. So we have the set camera just in case. And now this one's specifically only for the 3D. But then we also have then we initialize it, we update it here. Then here is the biggest stuff, the system, the light draw. And I'm going to get into this next, since it is the newest part. It's editor Sochi. I just went over that whole part, and yeah, that was a lot of information. So like I said before, that was Claude with all of the comments explaining how everything worked with the lighting system and rendering it on top of the scene. Now, I'm not going to include all that inside of the video, but yeah, that's how that works. So moving on. So we automatically have lighting, getting the lighting instance. And what we do, this is very important. So first, when lighting runs, it's in 3 order states, all before the compass passes. Before the camera has to pass, because we have to load up the shadows, we have to update the shadow lights, we have to update the camera for the active camera, then we have to upload every light and atmosphere uniform. That's how we update everything, so that way the shadows are corrected. And the next thing we do update and retarget those shadows. So it retargets the frame buffer to render the depth map, so it cannot happen inside of the begin mode. Otherwise, if it is in the begin mode, it's going to cause a lot more issues. And then the third thing is that we bind the depth texture to the actual camera pass. So here we'll just update it, update the camera 3D with the frame time, which really just delta time, and then we'll also render the shadow passes inside of the current scene, so that way the scene updates all of the meshes with that shadow. And here, this is when we actually begin it, process and update the camera. We'll update all the shadow maps and bind it into the materials. That way is good. Now the next thing we do normally is set, and everything else is good. So yes, as you see right there, the lighting system is the biggest change, and it has everything to do with it. And this is very important because the lighting is the actual horror texture to the scene. Now, specifically, the specific case with the lighting though, is that I did in fact use Claude to create it. But I also want to learn how to use AI correctly. So even though I'm currently doing source history scan and it just went through, so here I have an automation that just checked if there's any issues inside of the source code, and it did. But most of these are just there was no issue. Like here's an actual one. This is where you actually have save settings, scene entry issues, and this is how I automate it. But for creating the light system, which is all of this, there was a lot more errors. There has been a lot of changes with adding this. That's why I now have this MD. I also asked it to create an MD so that way I can understand it correctly. So and this is important whenever you're creating AI. You want to specify what the role actually is so it gets a persona. So I did a game engine graphics designer with over 20 years of experience evaluating across the engine using raylib 3D rendering framework. That way they actually know where to look for the information. It is a framework, custom engine, and then you also get the game designer for 20 years of experience. Now it doesn't exactly get it, but that's how it shows the information. The next thing was first actually generating the planning document, and planning it. This was important, detailed step by step, so that way I can understand it, and then the code itself can actually understand it. So I literally reviewed the generated document for importance of each in its exact order. I would like to know this too. That way I can understand how this all works, how it all connects, and it works. For context that is required by the user or major change in this overall functionality, and both these terms are used in HT format. Next, they will generate the lighting system by using the document and especially include comments on how each function works. Very important needing that which work. So I definitely say you're gonna have to remember this. It's gonna be very, very useful. And finally, we review the code for any bugs while in the programming phase. Once finished, use a clear and concise context to provide a summary for the completed task. That way everything is finished. So what I'm about to show you now is the official light system development plan that Claude had generated. So here's everything in order. This is how I wanted it to be, completely step by step, and it reviewed its own code. Now, I'm not going to show you everything. It's 15 different steps of everything. I'm probably going to show you the steps overall. Bell currently renders every 3D object through raylib's default shader, which is through the render 3D, draw the models and the wires, draw the message, and then buy the shader, for which every object in the project is actually from RL get shader ID default. The result is a flat, fully bright albedo with no directional cue, no fall off, and no equalization. For first person hurdles like subject veil, light is the primary gameplay and mood and instrument. So this is the highest value rendering gap remaining. This plan delivers a forward rendered multi-light level system with directional point, spotlights, a simultaneous hard shader limit. That is the hard shader limit. Wow, that sucks. A single direction shader map with 3x3 PCF filtering, a global atmosphere with ambient terms, distant fog and exposure, player flashlight that rides the camera, and the full editor authoring light inspector, then the full editor authoring and world file serialization, aka the lighting inspect, explicitly out of scope for this pass, deferring rendering and other aspects that are too much out of the bloom and are at the bottom of the page that for me to decide as for the target art direction before they are worth building. What this whole file goes through is the step-by-step process and why each step is important, from rendering the path to the shader asset itself and building the pipeline, to the light data models, to the light data on each model, the light system, singleton, that is literally everything because it has code settings, audio, asset manager, light system, and then the scene initializer. So that way everything, all the life, so that way the full life cycle. So what goes on here is that we first have to render path audit. We have to plan how we render everything, which is from beginning shader mode to auto binding the uniforms to putting down the mats or the materials, and then actually creating like the asset module, which is just shared pointers into actually their own assets, and even down to loading the rendered texture onto the models. Now, how this works is that we create the shader layouts and build a pipeline. We then create the light itself and the light types. We create the lighting system with the singleton skeleton. This is just the same thing with the specific order between settings, audio, assets, lighting to the scene manager. All of them use the same thing. And we even include what group of surface of light, like life cycle, what lights we use, how we inject it in the atmosphere, and even serializing it. We also forward. What we do next is just forward the lighting shader from GLSL inside of the meshes, inject it into the material, and then for every frame we would upload the uniform. So that way there's actually shadow. We would map out the shadow, atmosphere, and it keeps on going. And we have player, and it keeps on going all the way down. Because what I just went over here was the actually full function. Shadow mapping is last, and the atmosphere. And then this is how we actually put it into the game with the player flashlight, the editor tooling, light inspect, serialization, the settings integration, and quality scaling, and even shutting it down and resource ownership because we need our resources. So that's everything that goes out. And then and like I said before with the Claude code, it reviewed its own code. That way it checked if there's any like problems with it compiling with anything else, and everything was good to go. And finally, once again, we documented the release into the correct repo. So that's so that's what everything has gone over here. And that's how it planned out, created, and its way of thinking. Next up, where I'm going to have to do this, which is either creating point spot with shadow maps, which is large amount of VRAM. This one is most likely not going to happen because it does take a lot of VRAM. And every time I do load up the game right now, because I'm using 4K assets, it uses 4 gigabytes of VRAM. That's not going to work. The next thing is casting the shadow maps. And if the only target place exceeds the single map's full use, you got shadow distance. I do not know what that means. Linear sRGB pipeline tone map. Engine-wide changes every authorized color in every existing file. This would literally change the code, the color inside of every file and every single object, so that way it can change like that. So that way there is maybe even ray tracing, or each object itself will switch colors. Then the normal roughness map sampling. Depending on whether I use the assets from ambient CG will determine how I can load the map. This is the one I'm most likely going to go for because all I got to do is download the other stuff and then check the licensing. Lastly, there is light volume culling. Need only once. Authorized light counts routinely exceed the 8 limit. So this is just a few things that would need to go at the moment, but I still had to check it out. Most likely I'm going to just implement these two, and then I'll start to think about this one depending on how I feel about it. This is going to be a lot more. I don't know. I got to do more research on this, and this is most likely not going to happen because we're good right now. All the assets can load, and it would just be more code to check in the end. But that's with the lighting system. Definitely try to get Claude to do it. I mean, learning first, if you're gonna go for graphic designing, definitely learn it yourself. That way you can see stuff like this and actually see the effects of it. Now, my specialty is going to be more server side programming. That's why I am supporting in Claude, but I am going to also be. You need to learn how all this works in the background. So yes, the next thing that we have, the biggest change was that gameplay mechanic you saw earlier. So specifically what happens with that is there's a static, no worry about that. Whenever we complete a mini game, we get the data, the player, the buff, and then check if it is completed. Because if it is completed, essentially what we do, we're gonna run to complete it, but make sure the data says it's completed first. And then we're gonna get the buff that is requested by the player, by the mini game, get the buff and make sure it's not a no player, then we'll use the buff. We're good to go. That's even if there is the buff, of course. The next thing that we do is actually check enable and disable states. Check activators. We check the activators object and enable / disable. Check for activator object and enable / disable. This means that if there is the interactable object inside the player, we'll just enable it or disable it. That's what it is held actually right here inside the player entity. Oh my God, I cut that out. But yeah, inside the player entity. And that's how we can go here. Enable disable and activate it with the minigame. And you'll see it here at the bottom of minigames. We can just throw in that complete winning minigame logic with the data, the player, and the buff. Because the condition is simple right here. But if we go to the game like Simon Says, so yeah, if we do go to a game like Simon Says, we can still call the minigame buff. Problem is that the scoring, the data score specifically needs to check into the obstacles. And that way everything just checks into the obstacles. We still use the input system to get all the action, and then we'll be good to go. That is another big thing. That is the minigame. And the next big overall the next big overall change that I do want to note is actually the save system. So during my time, so while I was specifically building the world editor, so we'll go to here, we'll go to placement, and we'll also do save settings. It was specifically loading the world. Like I go down here, I want to get specifically the save files. I want to specifically get all of the save files. So that way I can just choose which word I'm at. That's where we have that's where of course error code. We just get a string of the file name. And for each entry inside of the side of the save path, so that way you could just throw it into a folder. All the day you would just be good to go. And we actually need to check the extension. So we get this lower extension from the top. Now this is the exact same thing from the asset manager that we used beforehand to get those loaded up before. It's like right here. And this is the exact same from the asset manager that we got from before. And then we just check if it is a .json, if it is continue, and then we just load it into the file name path. The biggest thing about this is that anything that is a .json can still go through, which is an error. It is an error issue. But the next thing that's where this comes in. So we're here in the world settings, and that's where on the bottom of the player, that's where you see where we get like for each file inside of the game files. If it is a save file, we'll just save it. Load file, we'll be good to go. Save default world .json. Honestly, oh yeah, I'll figure that out. Yeah, this is where we actually save and load the files by their name. That way they'll be good to go and they'll be set. Once they're completed, we just do a quick save for save.c string because all we need to do is just save that file name. And then if it does save, if it does save the world, then we just continue. Otherwise, it just failed to save the world. We do the same thing for the load, and then it'll be good to go. That is a lot of it. That's the save world, the full save world function. So that way you're good to go inside of this scene. But I did want to clarify more on this. So essentially what's going on here is that we do have the world editor. Specifically, this is the default scene. This is the player, can't see anything in the dark. But what the save system actually does this time is you can load up the rename files. Like I can go ahead and I would go here, go to game, resources, because we're actually loading the regular. We could just go to the scenes, world_2, copy that, world_2, and then world. We have the world, and then we go to the scene, we reload. Oh, I know what it is. So this is the thing I was talking about. So let me just copy this. Resources, scenes, paste it in here, world_2. This is where we actually have like world_2 we can load. That's what I mean by that's what I mean with the save system, to where the biggest change is that we can load different scenes at the same time. And all we got to do is store the worlds inside their own scene.json. Now, the default save world is still just going to save right here, which means I don't really need this, but I'm probably going to keep that for a minute because so this will be like a level 1, level 2 scene. So if I just want to save default world, load default world, I could just do that. That would be like the biggest way to go. And then the next thing I do have to add would be like naming. But reality is I just changed the name by the file. That would be about that would be everything with the save system, and the save system will be good to go. And finally, for the last part, it's been a lot. Like it's honestly been a lot. Like we're at 90 commits now for the whole project, and most of this project has been actually getting that input system to work, getting the settings to work, and actually all the systems down into the game. That's why the full goal for this month was getting that activator system down, and then I did the extra by adding that light system. Actually, adding the light system, actually adding the placement panels so that we could place objects better, and it was mostly good to go. So that's about everything I did this month. So that's about everything I did this month, and it's been definitely worth it. I say definitely give it a shot. Just go ahead and copy the code, or even better, just use Claude. Not for all of it, you still gotta understand it. You'll know that you'll need to know when you need to use Claude or not. Like all it does is gonna just add code or remove code. It doesn't check. Okay, that was about everything I did this month, and I hope you enjoyed the summary. And I'll be back soon with another video. Peace.